I'm here to talk to you about TypeScript, and specifically why I'm excited about TypeScript. And the reason I'm so excited is because I used to be sort of against TypeScript. I used to be pretty much against anything that wasn't like vanilla JavaScript when you try to write JavaScript. But a little bit less than a year ago, we started porting the Slack desktop application, which runs on Electron, entirely over to TypeScript. And we had a few reasons for that, and we want to talk a little bit about what we liked and what we didn't like, because when we started on this journey, I couldn't really find all that much information about what was good and what was bad about it from people who actually tried to port an application over. You found a few people like talking very high level about starting with a new project, but how do you actually port an existing application over? And the reason this is interesting is because I always want to motivate this a little bit, right? Like, why do we care about improving JavaScript as it is? I actually think that JavaScript is a lot more popular than people realize, or Node.js, and maybe more popular than even people in this room realize. And my two favorite examples for that are always the NVIDIA drivers and the Adobe Creative Suite, both running Node.js. Quick show of hands, who knew? Yeah, not that many people. So if you ever come across any Windows computer that has NVIDIA drivers on it, those computers are running Node.js. If you just open up any application in the Creative Suite, like Photoshop, InDesign, you're starting Node.js. And of course, if you're running any Electron application, something like Visual Studio Code, Slack, Atom, GitHub Desktop, now the list goes on forever, you're running Node.js. And in those scenarios, and that's the scenario I care about, in those scenarios, JavaScript is interfacing with native node modules. And those native node modules are likely making system calls at some point. They're interacting with the operating system. So in my world, in the world in which I write JavaScript, if I mess up, it's usually not a console error thing. It usually ends up somewhere in C++, blows up, and then my application has crashed. And because I'm running Node on my customer's machine, right, we're shipping the whole thing to customers, it blows up on the customer's machine, which is grade A terrible. It's not entirely the Slack experience people want. So we got to make sure that our code is structurally sound. And there's a few solutions to making sure your code is structurally sound, and I'm sure many of you have worked with giant vanilla JavaScript code bases. The most obvious solution to checking out what code does is to just read the source code, right? If you're using something like request and you're using request.get and you're wondering how that works, you could just try to find the source code for it, just grab for it, figure out what get does. Depending on how many dependencies you have, this might be difficult because you actually got bugs to fix and features to fix. So just constantly reading all your dependencies might be somewhat tedious and sort of defeats the point of using dependencies, right? You ideally just want to know what code does. So then people come along and write documentation, as they should. But the trouble with JSDoc and ESDoc and general documentation is that you need to trust your fellow developer. Your fellow developer needs to document stuff correctly, and also needs to write code that is correct. And that is increasingly difficult. I at least feel so. If you ever come across any documentation that was slightly out of date, that is my biggest nightmare, right? Stuff that is just slightly out of just by a month breaks my application. It's pretty terrible for me. So in summary, both methods don't really work for me, right? They didn't really cut it. So along comes TypeScript. Obviously, TypeScript has types. We're not going to really talk about that for too much time, but I want to quickly touch upon a few things that I really liked about TypeScript. The first one is that it's a superset of JavaScript, meaning that JavaScript is valid TypeScript. That was a really big deal. I don't think enough people talk about that. It's a really big deal that you can just start coding TypeScript, throw in all this JavaScript, and don't really have to worry about anything. It's just valid. It just works. Anything you can do in JavaScript, you can do in TypeScript. And you don't really need to turn anything into TypeScript in order to run the TypeScript compiler against it. Something I'm going to talk about a little bit in a minute. And it's not just that TypeScript accepts JavaScript just fine. It's also that TypeScript puts out normal JavaScript. There's no TypeScript that runs at runtime. It has a few Babel-like features where it does some pretty cool polyfills. But in general, TypeScript doesn't really do anything at runtime, which is important to me because I don't really want some magic black box that changes my code at runtime. And then two things that were really important to us as a team that is cross-platform, right? We built an application for Windows, Linux, and Mac OS. TypeScript had excellent support for all the editors. So if you, don't want to recommend a single editor, but whenever you're next to a shouting match about which editor is the best, it doesn't matter, TypeScript supports it, right? And if you really want to run the operating system known as Emacs, sure, right? TypeScript will be there. The same is true for the NPM world. And as an application that depends heavily on modules that we find on NPM and that we use, integration with NPM is a really, really important point. And I feel like at this point in time, if a module has definitions, type definitions available, they're likely in TypeScript. The other interesting part is that even if a module isn't written in TypeScript, of which there are, of course, many, it's very likely that the community has come in and written type definitions for it. We have about something north of 3,000 type definitions. But even if all those things aren't like the case, and you're using some obscure module that somebody wrote 10 years ago and it doesn't have type definitions available, TypeScript is doing a really good job of dealing with those modules. So with that said, I think I want to very quickly jump in and just show a second of TypeScript, just so we're all talking about the same thing. And then I'm going to talk a little bit about our experience dealing with TypeScript. So I get this wonderful piece of code here. It's currently just normal JavaScript, right? And we can study the code, but we don't really know what it does, right? We can just type anything, and our editor knows that there is a thing called sort people, but that's about it. I can right now write anything here, and who knows what is going on, because in the end it's just JavaScript, and if it blows up, it's going to do so at runtime. Between now and running it, there's nothing that's going to verify that this code is correct, right? And the interesting part is that if I want to turn this into TypeScript, which was the case for the Slack application, I can just start by renaming the file. And in the beginning, nothing really happens because JavaScript is valid TypeScript, and this is fine. And if you're looking at 300 files and you got bugs to fix and features to ship eventually, this is amazing. This is fantastic. If we talk briefly about CoffeeScript, I don't really have many opinions about CoffeeScript, but the whole notion that CoffeeScript was so drastically different from JavaScript was sort of always a non-starter for me, because I never really start with nothing, right? There's always something that I'm used to. And the other thing that we're noticing is that TypeScript is immediately trying to help me a little bit. If you can't see it, there's a little arrow down here where it's saying you can't just call this with a 5 because you're setting the input right here, the parameter, to an array. So we're going to assume that you want an array, right? And it's immediately saying, hey, you probably can't do that, just so you know. And even if I have little misspellings in my code, right? Right now I don't, but with normal JavaScript, this would be a thing that is really easy to miss right here. And I'm going to show you in a second how TypeScript is going to find that. So this by itself already runs. This is fine, right? And if I look at something like this result right here, TypeScript already knows that this is an array. I didn't really have to do anything. So if I want to check out what I can do with the result now, TypeScript already knows. It knows all the methods. It knows how those methods work, right, with all the various overloads. And if we look at the definitions for that, we can actually see what that looks like. TypeScript has this concept of definition files, and it ships with quite a few big ones. And this one is just the one for normal JavaScript, just normal, boring ES6. It's like a casual 21,000 lines of definitions, which right now, if you're a JavaScript developer, you're sort of expected to just know this, right? You're expected to know what kind of methods an array has available and how you use them, and how they all work together and what the overloads are. So that's something that's just supposed to be in your head. But right now, at least for me, as soon as I turn this into a TypeScript file, I don't really need to, because my editor already knows. And this is, by the way, not Visual Studio Code specific. This works with any editor, because it's just TypeScript in the back that has this information, can surface it to any editor. And the other thing is, now that I turned this into a TypeScript file, I can initialize this project as a TypeScript project, which really just means that we have this tsconfig right here, which specifies what our target is. Right now it's ES5. And then I can start the whole compiler in watch mode, which is exactly what you would expect it to be. It will just try to take this code and turn it into something useful, something along the lines of JavaScript. And if I open up this JavaScript file, let me just do this side by side. The interesting part here is that this JavaScript doesn't really do anything specific, right? This is sort of the JavaScript I would have written if I didn't have TypeScript. And this is, for me at least, a really, really big deal. This notion that there is no black magic. It's not like I open up this file and I have no idea what it's coming from. And with so many compiled, quote-unquote, compiled JavaScript files, very often I open them up and I'm like, I have no idea if this is good code or not, because it's all on one line. It looks terrible. This really helps, right? But let's keep going a little bit. We can now declare our intent a little, right? I can just say, hey, this sort people seems to be sorting some type of person. Let me just get rid of this. I can just say, what if we went ahead and defined an interface person, and this person interface has a name, and it has an age, which is a number, right? And then I can say this input is actually an array of person. There we go. Now, I can save this, and one thing happens immediately. Right now, it can't compile this file because, as you remember, I just like misspelled this local compare. And the reason it can't compile right now is because TypeScript now has like this nested information about my types. Right? I'm doing the sort here, meaning that TypeScript, if I just show you this in the autocomplete, already knows what kind of information I can expect. Right? It knows that both A and B are a person, and it knows what kind of properties are available on a person, which is why it knows that name is a string, and which is why it knows that I have local compare with an E available to me, but not the one without. And that's a mistake that, at least for me as a JavaScript developer in the past, was really common. Like this happened to me all the time, right? Like these little mini typos that I would eventually find at runtime or in like unit testing, but I would certainly not find them in my editor. And I didn't have the confidence right now in my editor that this is valid code. So that's pretty cool. But the other thing that's pretty cool is that if you look at this JavaScript right here, things still haven't changed, right? The types are just being stripped out. They're just not there. And of course, you can sort of go beyond that a little bit, right? If you want to, you can just say, hey, I want my TypeScript to compile my JavaScript a little bit. And in fact, you can see that I'm using an arrow function right here in sort that is turned into a function here, right? But if I just change that real quick from ES5 to ES6, I'm going to go ahead, and just like that, we have the arrow function back, right? And I could define a thing, like I could say, I don't know, class person manager. God knows what this is, right? And I could just say constructor. I could say, I don't know, this hello equals foo. This is not really allowed. I'm going to say hello. It's a string right here. Cool. And you can now see that we basically have some pretty simple JavaScript. But if I go back into my tsconfig and change that to ES5, TypeScript will again roughly write the JavaScript I would have written in that target language anyway, which is pretty neat. That's pretty cool. That is basically the demo portion of this presentation. It's basically to point out that TypeScript is really lightweight, which is what I like about it, but at the same time, really strong and extensible if I want to have some cool features. If I want to use async await, it can do that. If I want to have classes with public and private properties, it can do that. And if I want to require some things that are not my own stuff, it can also do that, right? Like the typical example is always if I say const request equals require request. Currently doesn't know that this is a node thing, right? Because I don't have a package.json or node types installed. But I could just go ahead, and if I had internet right now, I could just say npm install types request, and that would immediately fix the issue. And that is the case for like pretty much anything that is available in npm. So, demo done. Talking a little bit about more what that means for us, or what that means for us, right? So the first thing is that we could just turn on our giant JavaScript code base, we could just turn on the TypeScript compiler and didn't really have to do anything else, right? We just like threw it in there and we're like, well, I guess we're going to run this now every single time we save code. And it immediately found like a few little errors, which was cool, terrifying, but it was cool. You know, because in those places where TypeScript can sort of verify some of the basic properties of your code, where it like knows, hey, this thing should have a property called like hello, but you actually misspelled that. It already found all these like little tiny structural errors that really only happen if you encapsulate like 50 different promises, and they all return something else, and at some point somebody forgot what the original object looked like, and like a tiny mistake, and then somebody else copied that, and you all roughly know the story, right? So we immediately turned it on, found some tiny bugs right away. Didn't even do anything yet, right? And then our initial plan was that we would just start typing new files in TypeScript. That was the general idea. We wanted to just like try this on new files and then see how it goes. And because we at Slack, we really strongly believe in like checking our code over and over and over again. And basically by the time we're done, we like throw it all away and try it again, right? This whole iterative development. We were expecting that over time, TypeScript would just take over. But what happened almost right away is that working with JavaScript files felt a little bit dirty, like immediately, right? It happens very quickly. And one thing I personally, or I think my whole team really underestimated is the power of autocomplete. Everyone who ever worked in Eclipse and Visual Studio will be like, duh, of course, it's cool. But it's really quite powerful to not have to like check what is available in an object every single time. it's like really nice, right? Because every now and then you're dropped into a project and it's using, I don't know, not your favorite front-end framework, but something else. It knows. TypeScript knows, right? And in the case for me, for instance, like I recently started adopting Koa, and I didn't open the documentation a single time because I didn't have to. Not because I knew anything about Koa, but because TypeScript did, and that was good enough, right? And that's pretty amazing. That's pretty outstanding. So right away, as soon as we open up a JavaScript file, we're just like, ugh, gross. I don't know anything about this. Got to open up the documentation and if I commit code, I don't really know anything about it. So immediately you have this like very quick incentive where every single time we touched another JavaScript file, we're like, I'm just going to quickly port this over into TypeScript. It's going to take a minute. And if you just go with like the basic types and you don't add any of the super fancy features, that is very simple to do. It takes you a minute. So what happened is that instead of like slowly waiting years for the whole code base to like turn into TypeScript, it took a few months. And at some point, I became very quickly, we celebrated the last JavaScript file to be dead, and immediately went with TypeScript in the whole code base. A pretty cool moment. And then the other thing is that if you run TypeScript at commit time, you gain this like giant amount of confidence that you didn't have before. I hope that we're all using some kind of, Jesus, so many people. Welcome. I can barely see anything because the lights are so bright. I just see like this stream of people coming in. So anyway, committing with confidence. If you're the notion, hopefully some of you are using Slack. I hope so, because that's the company I work for. But if some of you are using Slack, the idea that you can't use Slack is what keeps me up at night, right? That is my fear. My fear is that I wake up one morning and somebody's like, oh, did you know that nobody could use Slack last night? That is like my biggest fear. So being able to run TypeScript every single time I commit anything, and knowing that my code is structurally sound. It might still be garbage code, right? But at least it's structurally sound. All the things that call each other sort of fit together. It's like Lego. You can build all kinds of turrets with Lego, but at least they're not going to fall apart, right? Which is a good feeling. That is extremely powerful. Which also brings me to my first downside. There's a thing called TS-lint, and I'm very happy for the people that work on TS-lint because we didn't work on it, and it's pretty good, but it doesn't even come close to the amazingness that is ESLint. ESLint can do all kinds of magical things. I don't know if any of you are using it, but whatever dumb idea you might have in your team about a thing you want to enforce, ESLint will do it for you. Right? Which is amazing, right? It's like, if you want like certain variables that declare certain things, always will be like prepended with a certain emoji, ESLint will do that. TSLint will not. TSLint is like pretty bare bones, and it uses like all the ESLint basic features, but extending it is a little bit harder. So as we like ported some things over, we had to let go of some ESLint configurations and just try to find like ways around it. But it was still pretty good. And then, and I think this is honestly the biggest downside of TypeScript is, so I used to be a native developer and my whole team is filled with native developers, but these days, especially when you try to hire for JavaScript positions, very often you will encounter people who have never seen a typed language. They have never worked in Visual Studio or never worked in Eclipse. They have never written anything like C++. And the whole notion of some of the more advanced features of TypeScript, things like interfaces and types that extend themselves, generics, union types, that kind of stuff. If this doesn't mean anything to you, right now it's because you've been working in JavaScript and you didn't have to, and that's great and perfect. But this can mean that we are basically paying this little tax of whenever we want to introduce a more junior developer, a more JavaScript-focused developer into our code base, we sort of need to like educate them about these basic things. Right? These like basic, what is an interface? What is a union type? What does it mean if there's like a T extends K, right? And every now and then we come up with these like super cool constructs of things we can do in TypeScript, and then the response is that's really cool, but also unreadable, and nobody knows what that does. Which is, one of the issues. Like we all really like JavaScript because it's so lightweight and so quick and so cool. And if you use TypeScript to its fullest extent, it has like all this fluff around it, which I enjoy because it keeps me confident and keeps me like sleeping sound at night. But if you want to have your code available for a bunch of people out there that you hope are going to contribute to your code, it's a little bit harder, right? Which is why every now and then you will still see me in like currently building a new project in the Node Foundation called the Electron Installer, and for that we're using standard.js. Mostly because I think it's easier for everyone to contribute, and you don't need to learn anything in order to then jump into the code base. But right now, if you want to work on the Slack desktop app, you first get a basic course in typed languages and what union types are, which is kind of nice. So, in summary, This talk was pretty short, but that's already it. If you have any questions, you can find me at felix.fun, which is, by the way, great TLD. Recommend that everybody goes and buys a .fun domain. It is extremely cheap. And if you have a complicated last name like me, it is amazing. OK. We got about 3 minutes for questions if anyone has any.